I would highly advise, again, that you try these on your own and then come back and attempt them, because I'm going to go pretty quickly in solving them. So here's HCN at the bottom. Okay. Carbon has 4 valence electrons. Hydrogen has 2. Or sorry, has 1, but there's 2 of them, rather. Chlorine has 7, but there's 2 of those. So plus 7 times 2. So this is 14, 15, 16, 20. I have 20 electrons to put that together with. I'm going to start by putting an odd man out in the middle, carbon. It does not matter if you put hydrogens in one location or another versus chlorines in one location or another. This is not a 3D rendering. Okay. I only put 2 around the hydrogen because it can only take 2 electrons total. Okay. So this carbon has 8. Each of the chlorines have 8, and each of the hydrogens have 2. Okay, let's count, make sure we get 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So this is good, check. Okay. Carbon, this is another way to look at it. So each of the 2 electrons that are between these 2 guys is a bond. Okay. This one's a challenge. Carbon is equal to 4 valence electrons. Hydrogen has 1, but there's 2 of them. And oxygen has 6. So that's 8, 12 electrons. Okay, we have to put this together with. Carbon, I'm going to put in the middle because we seem to be doing that a lot. Okay, let's see. This looks happy. Hydrogens look happy. Carbon here looks happy. Oxygen there looks happy. Let's count. Make sure we have 12 valence electrons. 1, 2, 3, 4, 5. I'm sorry. 2, 4, 6, 8, 10, 12, 14. If you have too many, that means you need to take some of these out of here and here and put them between instead. So now what this would look like is C, H, just like that. Okay. So here's carbon. It's got 8 around him. Oxygen has 8 around him, and each of the hydrogen have 2. So 2, 4, 6, 8, 10, 12. Now this is right. What it's actually going to look like is this. Okay. I have another trick to teach you. And you can consider hydrogen over here in this bit. These have 7 valence electrons. They need 1 more. One more electron to make that octet. They get that by a bond, which means that these guys bond 1 time. These have 6 valence electrons. They need 2 electrons. They get that by bonding twice. These have 2 bonds. These have 5 valence electrons. They need 3 more through 3 bonds. So things here, bond once, bond twice, 3 times, and these bond 4. Carbon ends up in the middle a lot of times because it has the most bonds that go to it. Let's go back and look at what we just did. See how carbon bonds 4 times? And chlorine and hydrogen bond once. Chlorine bonds once. Remember how I said hydrogen could be considered over here? Excuse me. That bonds once too. Oxygen bonds twice. Look here. Twice. Carbon has 1, 2, 3, 4. That's a straight line bond, okay? Pretty neat to be able to do it that way. So, sulfur has 6 valence electrons. We know that hydrogen has 1. So 6 plus 1, and there's 2 hydrogens, total of 8 electrons. I'm going to start with sulfur. This stuff is stinky, by the way. Got that? Or just like that, same thing. Now let's look over here. Sulfur has 2 bonds. Guess what? This works. Okay, so now hydrogen bonds once. We know that. Carbon bonds 1, 2, 3, 4 times. Nitrogen bonds 1, 2, 3. Ah, cool. Let's try to see if we can do this last one together. I'm going to put carbon in the middle because it bonds the most. 1 bond to hydrogen, 3 bonds to nitrogen. Now, you see how this would be the same thing as here, carbon would have 8 electrons. Nitrogen only has 6. That's why you have those 2 lone pair of electrons. Now, I did a fancy shortcut way to get to this, but let's do it the real way now. Hydrogen has 1 valence electron, carbon has 4, nitrogen has 5, total of 10 electrons. Let me count this. 2, 4, 6, 8, 10. So use that little quick rule for you when it is in need. So when you need to use a different method of getting the answer, that's when I would suggest you use that one. Okay? Thank you much.